Okay, let's get started. So what we're going to do first is we're going to load up some data. In this case, we're going to use some data that we've acquired from Epic through just a simple extract mechanism. This data reflects all of the events that have happened to patients in this particular hospital over about a 2-month period. Now you can see that from the last time that I loaded it, it remembers the mappings of the columns just for convenience sake. But the important thing to see here is that there are actually 3 absolutely required fields for a data record to be a valid event for our analysis. The first, as you see on the left side here, is the timestamp. The timestamp tells us, of course, when something happened. In the center of the screen now, you'll see the timeline ID. The timeline ID tells me how I'm going to link this event with other events in the same context. So here we're assigning the timeline ID to the encounter ID. So that means that each of our timelines is going to show everything that happened to a specific patient during a specific encounter. Then finally over here on the right, you see that we map the event name to transaction type. That simply tells us at that time, related to that case, what happened. So this would be things like logging the patient arriving, ordering a lab test, receiving back an X-ray result, whatever happened that we logged. Now those 3 fields are the only ones that are absolutely required. But if in fact we have other data available as part of our events that we think might be interesting to help us with our breakdown analysis later, we can grab it as well. And so you see some of these columns have these purple headers. And so that simply means that we've assigned an attribute to those so that we can use them later. So we're going to grab things like means of arrival, how they came to the hospital, day of the week in case I want to see how maybe weekend versus weekday staff works, acuity level. And then if I wanted another one, by the way, I could just drag and drop a new attribute on that particular column. So I've already loaded the data, so we're not going to take the time to do that here. As soon as the data is loaded, what we're presented with is our project overview page. And what this is going to give us is some basic facts about all of the different timelines or different cases that we were able to extract from that data set. So in the upper left-hand corner here, you can see that our data set had actually just under 450,000 events, meaning records of something happening to some patient during some encounter. And we were able to translate that to 23,472 timelines, which in this case, of course, means the same as encounters. In addition, I can see some basic statistics that say that the duration, meaning from start to finish of any particular encounter, on average is 5 hours. But in fact, we can see some unusual data here, like it could be as long as 35 days. Obviously something unusual there, so we're going to investigate that a little bit more in a moment. We can also see how many events or how many different things we do to patients, and on average we do about 19 different logged events with a patient, but in fact, at least in one case, it was as high as 102. How many of those things we do are unique? What are the gaps between any 2 consecutive steps? And we also try to give you some insight as to the variety of data and event types that were extracted when you load the data. So you can see that we found 46 different types of events. And in fact, if I click on this, it'll bring up the panel and show me, here's the full list of events that I was able to extract from that file. And you'll notice that I could sort it by the number of times that any particular event occurred or how many timelines it impacted. You'll also notice that in some cases, you'll notice that there are these little icons next to the names, right? So for instance, if I look at this lab ordered event type, you'll see there's this little microscope icon. That's simply something that we did to make things a little easier to spot, and you'll see that in a moment where that benefits us in the timeline view. So I could load up icons that we provide, your own custom icons if you want, or if you don't have icons, you can simply use color dots, okay? So let's exit here. In addition to be able to seeing the details about all of the different types of events, we can see what types of events typically start and end our process. In this type of a situation, there's no guarantee that the same type of event will always begin or end a process, so it's important to understand the distribution of how one type is favored over another under certain conditions. And let's go in and start to take a look at one of the ways that we would actually be able to analyze our data, and that's through our timeline analysis. So within the timeline analysis itself, what it's showing me here is each one of these horizontal sequences of events represents a timeline, which again, in our case, because of the data we loaded, that's going to be a patient encounter. Each of the circles on the line are showing me in chronological order what events I know were associated with that particular case. And you notice as I mouse over them, it will tell me what the event is, what its values are, those sorts of things. Okay, and where you see gaps between events, those gaps are in fact proportional to the amount of time that has transpired without anything happening with this particular case. So in some cases, you might see that you have very long gaps, in fact, where nothing has happened with the patient, where the patient is simply waiting and we're not recording having done anything. Now, if I drill into one of these timelines, right, I get to see a different view. This is what we would call our case analysis view. And so what this shows me is this shows me the superset of all events on the leftmost column, the superset of all events that have happened to this particular patient. But you'll also notice to the right, we see several more columns. And what that is, that's the result of an automatic analysis that's done by the tool itself to determine what events might in fact occur with each other. So for instance, I might have situations where I detect that some patients have lab tests and others don't. So therefore I could detect that in fact there's a sub-process or a parallel process where we do lab tests or radiology orders, or some patients are admitted and some are discharged. So without you having to tell us anything about the data, we're able to actually discern that by simply analyzing the events themselves. So let's exit out of here. Now, another very interesting way to look at this, right, is that I can tell you that if you go down and you look through all of the different types of cases, you'll find no two that actually match each other in the actual sequence or certainly in the timing as well. And so you might say that, well, with all that variability across all of these cases, are there any general patterns that might actually apply? And we actually provide you with a tool to help you with that, and that's our schema analysis. So let's begin by having the software actually generate a process schema for us from those events that we loaded. We do that by simply saying, let's initialize a new process schema, and then asking the software to go and figure out what the default milestone should be. Now, what do we mean by default milestones? Well, we let the software do the bulk of the work for you because it can go through and it can look across those 46 different events that we loaded, and it can determine which events most reliably occur in the same position of the process flow from case to case to case. Doesn't mean that everyone will follow it exactly, but in the highest percentage of cases, these milestones will be very reliable. Now, it, of course, is going to set a very high bar for that, so it's going to pick those which can most reliably depend. But you, in fact, could come in and you could say, well, you think you know better and want to see some other things. So you might say, well, I want to also see when the patient is admitted and maybe when they depart the emergency department. And whatever we select, we then simply say, generate the schema. And what you see here is based on your data and everything that it was able to analyze from those events, it tells you the sequence in which things happen most reliably. Now, this is more than just a graphical diagram. Yes, it's a nice picture that allows us to look at this and avoid having to go and manually try to draw pictures like this as people might have done with Visio diagram tools or things like that. But if I actually save this out, we can see that it actually becomes an operational monitoring tool. So now what I'm seeing is the number of occurrences of these events in these locations across all of my cases. Right now, it also happens to show me something else, which is the thickness of the line is set to show me the number or the count of timelines that actually go through that particular path. So the more bold the line, the more cases follow that path. I could also look at this based on the length of time they spent in between these particular steps. So now the thickness would indicate where I spend the bulk of my time. I can also go and I could ask it questions like, I understand that a lab order, for instance, wouldn't make a very reliable milestone simply because I could order a lab test anywhere in the sequence, right? I could do it immediately after the patient arrives. I could do it anywhere in between, and I might even do it just prior to making a decision to actually admit or discharge them. So I might want to have an understanding of how they're distributed, right? So I could come in here and I could say, let me see where lab orders fall, add it as an event. And now what we're seeing is we're seeing the percentage of lab orders that occur in each of these positions in our flow, okay? And by the way, I could specify that this is now showing me the position of the lab order relative to being before its next event or following a particular event. So again, anything to help you get a better understanding of what's happening within your data without you having to go off and do a bunch of manual work. So let's take it up another step. So there we saw the most general way of looking at the flow of these different cases. Now maybe I want to go in and analyze to find more about the consistency or variability of how things flow through these cases. And I'm going to do that using something called a path analysis. Path analysis says I'm going to suggest to you the most important events that you should look at based on looking at all of those cases. So in this example, right, we had 23,000 cases. It says based on that sample, down the left side, I see those events which in fact make the most sense for us to analyze. Now, of course, the software is trying to help you here. You could go in at any point in time always and override the software's suggestions. So if you said, well, I also think that a consult call is important, or maybe lab orders are important, I can always enhance this and add more events to it. And you notice that as soon as I do that, it immediately recomputes everything. So what is the path analysis telling us? It is a frequency distribution of the number of cases that follow one sequence of steps versus another. So in the leftmost column, we can see there are 434 cases, 1.87% of them, that go from patient arrived, triage started, ED class set to emergency, triage completed, and so on. Whereas in the second column, we see that we still record patient arrived as the first event. We then record that triage was started, but then we see that it jumps down to ED class set to fast track. Well, it raises a question, right? Not all events are necessarily important depending on the kind of analysis. So that if I just want to look at the interaction between my staff and professionals with the patient, I might say, well, that's more of a clerical thing. It's important in tagging patients, but it's more clerical than it is hands-on. And so I could go in here and I could actually now say, well, let's actually turn that off. In other words, let's eliminate the need to track that, and we eliminate the need to track ED class set to emergency. And what you see is as we do that, it immediately recalculates the frequency distribution based on those new degrees of freedom. So now I see my first column is up to 900 cases, 3.88% that follow this particular pattern. Now, where is this helpful? Well, one place that this is very helpful is to try to spot behaviors or execution patterns that might in fact either be suboptimal or in fact might actually be completely non-compliant, right? Something that might in fact be a serious problem. And as I start to scroll to the right, you can see that I start to see more and more unusual variations from that initial case that we saw. So if I'm an expert looking at this, I might see that there's a particular pattern that concerns me, and I might say that these 37 cases, I don't understand exactly why this pattern would happen with all this jumping around. I can highlight that and immediately apply that as a filter. Now we're looking at our timeline view, but instead of seeing all 23,000 of the cases found when we loaded our data, it's showing us just the 37 cases that matched the pattern that we just saw in our path analysis. Now, every time we do that apply filter, and you're going to see that a lot in different types of analysis that we can do in the product, that actually creates a filter. And so I'm going to now clear my filter so that I go back to all of my 23,472 cases. And let's dive in a little more closely now. So how does one begin analysis here? Well, one of the things you might want to do is you might want to say, well, let's look at those metrics again that we saw in the overview page. And remember, we saw that duration that looked unusual, right? We said that we could have a case that could last up to 35 days, even though the average was 5 hours. Well, I can dive into that more deeply now. So what I'm looking at now when I click on that metric is I'm looking at a frequency distribution, the cases by their duration. So this histogram is showing a nice big spike at the beginning, which tells me that most of my cases are done in far less than 35 days. But you'll see if I start to drag this slider, you'll see how it begins to automatically recompute how many cases are above or below the threshold. So let's say that I am very forgiving and I say that I'm just interested in cases that might go beyond 2 days. So I set my slider to 2 days, and what I can see is that there are 116, about 0.5% of my cases that actually exceed the 2-day threshold. Now, if I'm trying to understand where perhaps we're not performing optimally, I'm probably much more interested in these exceptions than I am on those that actually perform the way I expected. So here again, I can apply this as a filter, and now I'm looking at just those 116 cases. Now, one of the things that I could see that's interesting, right, is that as soon as I do that, all of these metrics across the top are recomputed. Okay, they always reflect the current, in this case, encounters in our analysis. Now, when I did that, one of the things that I could look at is I could see that, in fact, the last event, meaning the last thing we do in these cases, well, in this case, 61% of the time is some unusual event called temporary patient is identified. Now, what does that mean? We had to find something more about this patient to complete the record before we could close the case. So it's not necessarily related to anything clinical. It's just more of a bookkeeping thing that this case in the system was shown as remaining open. I couldn't close the case, but in fact, the patient has long left the institution. So that's interesting. So more than 60% of the time when these cases go far too long, the last thing we do is having to go in and fix some clerical omission or mistake. So I'm going to apply this as a filter as well. And now I'm seeing a subset of the subset. So now we're down to 71 cases that are both greater than 2 days. And the last thing I do is go in and fix that mistake. I'll hide the durations between the events, and you can see that each of these cases does in fact end in exactly that same type of event. That's interesting, right? We know that this happens and it seems to be related to our long-running cases, but we don't really know if it's a problem. We really haven't done anything quantitative yet. So what we can do now is we can actually bring up our time range chart. And it happens to remember from the last time we did this analysis for convenience, but let me explain that I'm going to measure from the patient departed from the emergency department event. I can pick any event I want, but that's the one. And I pick that one simply because when the patient leaves the ED, that'll capture both admissions and discharges. So it's a good, reliable point to measure from. And then we're going to measure from there to when we actually do this temporary patient is identified step, which is the fixing of the problem, which allows us to close the case. And what you see immediately at the bottom is you see that, well, the minimum amount of time it takes us to fix this in these long-running cases is, in fact, 42 hours, almost 2 days. The average amount of time is 9 days, 10 hours, and the maximum time is 35 days. So that's where that 35 days comes from. And in fact, what you can see below is you can see a distribution that across all of these cases, these are the different amounts of time it takes to fix the problem. And so you can see this is an issue across the entire interval of cases. Now, that's interesting. And in fact, if you're a CFO at this organization, you might look at this and interpret it a different way, which is that, because it takes us over 9 days to go in and fix a mistake like this, that I have to wait an extra 9 days before I can send an invoice or submit a claim for reimbursement. I mean, clearly that's a significant financial burden on the hospital. Now, I can take this a step further, though, and you might say, well, is there any rhyme or reason to why this might happen? And so we could bring up something like our breakdown chart. And since we're only looking at cases that, in fact, are taking too long and require us to fix mistakes, I could come in and say, well, is there anything that I could possibly have known early on? So maybe at the time that the patient arrived, maybe it has something to do with the day of the week they arrived. Maybe we have a problem on weekends more than weekdays. So let's see how it breaks down by that. Well, not really. I mean, all of these are relatively evenly distributed. Tuesdays are a little light, but then Tuesdays are light overall. If I want to break it down by acuity level, again, all pretty evenly distributed. Maybe I'd expect my 12s and 13s to be a little higher, but nonetheless, nothing really stands out here as obvious. Now, what's interesting, though, is when we switch to look at how they arrived at the hospital, we actually did find something kind of interesting here. And as you probably would agree, in an emergency department, the vast majority of patients come to the ED under their own power. So either someone drives them in their own vehicle or they drive themselves. In fact, generally, this happens on about a 4-to-1 or 5-to-1 ratio to those that come by a third-party transport like an ambulance. So the fact that an ambulance represents 50% of the cases that run too long and require this error correction at the end, that's notable. That's certainly much higher than we'd expect in the normal population. And in fact, if I look over here on the right, I see that life flight, that actually is almost 10%, and we know that in reality, that's usually well less than 1%. So it raised a question, which is maybe this has something to do with third-party transport. And in fact, as somebody began to dig into this, they found that's exactly what it was, because there were certain informational documentation or other information that had to be passed on by the third-party transport organization that prevented the case from being completed. And because they are, in fact, by definition, third party, they don't work for the hospital. I can't just go and very quickly get an answer from them. I have to actually go and track them down to try to get those types of answers. Now, in this data set, we're not actually allowed to show anything related to not only patients, but also to staff, right? But you could imagine that if in fact I did have staff names here, I knew who the admitting nurse was, I knew who somebody else who was working who maybe is the liaison with the emergency services people, I might be able to see if in fact this mistake occurs more under one person's shift than another person's shift, so that I could see if I could go and hopefully retrain them, or maybe change something in my procedure that would allow us to eliminate these types of mistakes. So now I'm getting to something much more actionable. Now again, as I said before, every time we do one of these things, we create a filter. These filters are actually very powerful. Like here we said, show us the cases greater than 2 days. If I wanted to, I could invert that. Now it's going to show me the cases less than 2 days, but still ending in that type of an event, of which we see we have 466 cases. If I wanted to actually inspect those 466 cases, I can delete one of the filters. And now I'm looking at just those cases across all of them, whether they're more than 2 days or less than 2 days, that end in this error correction event. So we still have about 2% of our cases. The last thing we have to do is go in and fill in some missing piece of information. Let's clear that event as well and take a look at some other capabilities. I'll turn the durations back on so we can see some of the differences in spacing here. Okay. So what do we want to see now? Well, one of the things I might want to also do is I might want to try to do some visual inspection. I mean, right now we have 23,000 cases, so we're not going to scroll through them all that regularly. But I might have a belief that maybe there's something related to lab orders and turnaround time on cases. So this is one of the reasons it's nice to add those icons. I'm going to click on this lab order here. And over on the right, you can see it tells me that across all my cases, lab orders happen from not at all, 0, or they happen at least once in 12,408 cases. And I could go and I could see that they happen 10 or more times, meaning 10 or more different lab orders in 53 of these cases. And in fact, one case was as high as 20. But I want to do something else here for visual inspection. I want to go off and I'm going to say, let's align by that event. And what this allows me to do is, before, all of our timelines were left justified as if they all started at the same time. And of course, we know that's not true. Different patients come in at different times, one shortly after the last. But here we might say, well, the way we want to look at our cases, though, is we want to line up all of these lab-ordered events, at least the first one, as if they all happened at the same time. And that'll give us the ability to visually inspect what happens immediately prior or immediately following. Now, again, admittedly, we've got 12,000 cases with lab orders, so scrolling through is not all that helpful. But one of the things that stuck out when we do this is you notice that this icon, this little flask and test tube with the little check mark, is the icon we assign to the lab resulted event. So since these timelines are chronologically ordered, how is it that we in fact are getting a result prior to actually issuing the lab order? Well, there are a couple explanations for that. One fairly innocent and consistent one is that there are certain tests that we can do as spot tests in the ED, and that we could record as a result where it doesn't actually get processed as a full lab order. But it could also indicate perhaps we have some other issue happening here where we have misassignment of results with lab tests or something like that. So let's go back to our original view. We'll align it by the first event. Let's say that somebody came up with a question and said, look, I believe there are cases where we could have results before lab orders. How often does that happen? Well, we provide a capability called our query mechanism where we can go in and begin to ask those kinds of questions. So what do I expect to happen? I expect, first of all, we're going to order a lab test, and then eventually we're going to get a result back for that lab test. But that's not really our question. Our question is, how often might we get a lab result that is not preceded by a lab order in that sequence? And so we can immediately go off and search, and as quick as that, we can see that not only does it happens 391 out of our 23,000 cases, about 1.7%. And by the way, those questions we're asking don't have to be simple like that. We could say, well, we only want to do this perhaps for patients that arrive on a particular day of the week. So we might say for patients that arrive on a Sunday. And we might want to say, well, we don't even care about just all of those, even if they arrive on a Sunday. Maybe we're only concerned for whatever reason for those patients that might ultimately be admitted. And by the way, for whatever reason, we would say that that admission should happen no longer than 30 minutes after the last lab result. So we can specify a time interval between any of these steps. And of course, a different time interval between any pairs of steps. So now we're going to say that should be only cases that took more than 30 minutes. And oh, by the way, we'll say that the receipt of one result without having the order in, that might be easily explained. So let's not get confused by that. We'll say only show me those where I've gotten at least 2 results without first having the order in the system. So now we've built a fairly complex query, but just as you saw before that quickly, we can narrow it down, and these are the 48 cases that meet that condition. Another thing you can do with queries is these queries can be tied to alerts. So that if I could define a condition like this and say that if this ever happens, I want to be notified immediately so that I could go and begin to investigate and maybe take action, that's a very powerful thing for monitoring your processes after the fact. So let's take another look at that type of monitoring and analysis capability. Again, I'm going to clear my filters so that I can go back to our complete data set. And let's, in contrast, look at something called protocols. So a protocol is kind of the inverse of a query. A query says, let me define a condition and then find me every timeline, or in this case encounter, that matches that condition. But what I want to do here is something a little different. With a protocol, I want to say, I'm going to define a set of rules, and I want you to tell me every case that violates these rules. So not matches them, but those that do not match them. So in this case, this is a fairly simple example. We're going to define a very simple admittance protocol. And it's set up that it says that once we have a record that there was a decision to admit, we expect to see a patient transferred record, then a patient departed from the emergency department record, and then eventually a patient admitted. And for our own performance goals, right, we're going to say that we would expect or hope that patients depart the ED in less than an hour. So we don't want to see any case take longer than 1 hour. So I can go off and I can say, well, that's fine. We have this rule, but we'd like to test it. We'd like to understand how would we have performed against this rule historically. So I can come in here and I can say, show violations. And what this is showing me now is it's showing me not only that the protocol would have been violated so many times, it's showing me the precise root cause of why it would have violated the protocol. So I can see that decision to admit actually was in the wrong position in my sequence. It happened, but it happened in the quote-unquote wrong place. Or by the way, it happened more than once, the wrong count. Or the patient admitted step was missing or was in the wrong position. Well, that raises an interesting question, right? So sometimes maybe we want some forgiveness in positioning, right? Because maybe we allow people to have some freedom. So for instance, if I said the patient transferred event being in the wrong position, not really a big deal because we know sometimes that might be recorded before the patient departed event. So we can come back and we can make this protocol more forgiving. So we could say, well, the patient transferred event is allowed to float anywhere between decision to admit and patient departed, as is the patient departed event. That's also allowed to float. And by the way, in addition to being allowed to float, I could specify that a particular event type might be allowed to occur between X and Y times. It could actually happen concurrently with some other event, or it could be completely optional overall. And when I make these changes, I can immediately test it and see how would that have affected this to eliminate perhaps some of those false positives which might discourage people just because it seems like noise. So again, just like everywhere else, I could, of course, apply any of those conditions as filters, go back, just inspect those timelines, just like you saw us do before. Now, all of these capabilities that you've seen, right, these are all about analysis, and there's a lot more analysis here than we'll have time to get into in this session. But one last thing that I'd like to show you is, well, there are different types of users in your organization. There are those who might come in and do this type of analysis either for research reasons or quality and safety reasons or process improvement reasons. But there might also be people who simply want to monitor from a management perspective how well we're doing. So now beyond the analysis that you've seen me do here, there may be times when we want to provide the results of this analysis to people who are researching quality and safety issues, process performance issues, or anything else where they really need to dig into the data to understand how things are working at a more fine-grained level. You may have certain managers and other professionals who want to understand, though, the results of how things are working so that they can monitor performance and changes in performance day to day. For that, we have a capability we call our dashboards. Now, of course, you're probably very familiar with dashboards from the myriad BI tools that are in the marketplace or probably even being used in your organization. To be very clear, as we've said earlier, this is not a BI tool. This does not replace those BI tools. This is purely a convenience mechanism whereby people who don't want to go in and do the analysis can actually monitor information derived from that analysis in more of a dashboard-like fashion. So maybe they want to look every morning to see how they're trending against certain performance goals. So this is designed to be very easy to use. I can come in, I can have a number of predefined dashboards. I could come in and modify a dashboard. I could change the layout of the dashboard. So maybe I want my dashboard to be 3x4, and I want to add new metrics to my dashboard, so I can edit it and say, well, let's add a new metric here. I can pick one from the available library. If I don't have one in the available library, I can go in and I can simply begin to create one using a wizard mechanism. So again, designed to be very easy. Nothing can be broken here. It's just meant to be a very simple way to be able to go in and create a dashboard for someone to be able to use.